In the last video, we performed solution stoichiometry to figure out how much copper hydroxide we could make from solutions of copper sulfate and sodium hydroxide. We used 20 mils of 0.25 molar copper sulfate and 30 mils of 0.2 molar sodium hydroxide, and we found that the sodium hydroxide was the limiting reactant, and which means that the copper sulfate was the excess reactant. So another type of problem that we could add on to a problem like this is asking how much of the excess reactant remains in the solution after the fact. And since we're dealing with solutions, we would look at what the concentration or molarity of that would be. So what I would say is you can start at a couple different points, but I like to start with how many moles of the limiting reactant we use. Because you use all of your limiting reactant, and we can use that to figure out how many moles of the other reactant we used, and then how much is remaining, and then figure out what the resulting concentration would be. So if I use 0.006 moles of sodium hydroxide, I'm going to use 1 mole of copper sulfate for every 2 moles of sodium hydroxide because everything reacts in mole ratios. And we figure out that we would use 0.003 moles of copper sulfate. Since we started with 0.005 moles and we use 0.003 moles, we can say that we have 0.002 moles remaining after the fact. So we had that initially. Track that. So we get 0.0020 moles remaining. And so we take that and we plug that into our molarity equation to figure out its concentration. You have 0.002 moles of copper sulfate. And we had 50 mils of solution now because we reacted 20 mils of one thing, 30 mils of the other. That gives us a total volume of the solution of 50 milliliters, which is 0.050 liters. So we would get a resulting molarity of 0.04 molar copper sulfate at the end of this reaction.